In 2.0, we finished creating our Git repository and created a test Go file. So in 2.1, we're going to take that repository and we're going to start building a web application. We're going to start with something that's really, really basic. It's going to be 15 lines of code. And with it, we can sort of cover the basics, get your feet wet, and get you familiar with some of the standard, the HTTP package and how do you build a web server with it. I will warn you now that almost all of this code is going to get thrown away. That's kind of just how web development works, especially when you're just learning something new. You write some code and then you slowly figure out better ways to do it, and you just throw that stuff out. This is completely normal. Just expect it, be used to it. Even in professional development, a lot of the time you're taking code that's there and you're replacing it, as your needs and your requirements change. So don't feel, discouraged if you find yourself ripping out some old code or things like that. It's completely normal to be writing code and then ripping it out and throwing it away and fixing it and making it better. Even I and other professional developers will see code that we wrote maybe even 3 months ago and think, man, what was I thinking when I wrote this? So it's not just you, it's everybody that has this, and it's natural, it's part of learning. So we're going to go ahead and I'm in the LensLock directory. This is where we started before. I'm going to check out a branch. So checkout -b means that we're going to create this new branch. I'm going to call this 2.1 a basic web application. So you don't technically need to make a branch, but I'm making a branch just to sort of keep track of these as we go. It just makes it a little bit easier to branch off when you're doing your work. So I'm going to open the entire directory inside of Atom, and then I'm going to open this main.go file. So inside of this, we're going to write this program. So we don't need to change the first line. It's package main. That's what we want. We want this to be where we're running. The imports will change, but I'm going to go ahead and just delete everything for now. So the first part is our imports. I'm not sure if I covered this in the other video, but I have automatic importing set up. So if I save, it's going to delete those. There are some downsides to that, but it's generally pretty helpful. The next thing we're going to want to do is create a function this is our function that is called anytime somebody comes to our web server or our web application. So the first argument we want is a response writer. So this is part of the HTTP package, and it's an interface that we take in. And then we're going to take a pointer to an http.request. So this is our function that we're going to eventually run anytime a web request hits our server. The name of this could be anything you want. I could name it John. I could name it do stuff, whatever you want to do. So I'm just going to call it handler func for now. So the reason I'm calling it handler func is because one of the common names for it is a handler or a handler function, because it matches the http.handler func. This is a type that defines this function. So I just call it the lowercase version of that just because it goes in line with what that is. Later on, you'll see that we change that. We don't call them all handler func. I'm just doing that for now. So while we're inside of this, we're going to call format.fprint. If you've used format.print or printline, this is roughly the same, except the first argument you tell it where you want it to print to. Whereas with just format.print, you're going to tell it I want to print to just standard out. And I think I mentioned this before, but it's technically fumped, but I just hate that pronunciation, so you probably won't hear it from me as much. So the message we're going to write is some HTML. We're going to put an h1 tag, which is a heading tag, and we're going to say, welcome to my awesome site. Then we're going to close that h1 tag, and that is our entire handler function. So it takes in a response writer. This is where we write our response to the user. A request has information sort of about the request that the user's making, and we can use that to sort of get things like the user's IP address, stuff like that. But we're not doing any of that right now. We're just going to send a message back no matter what user it is or what information's there. So we have that. So now we need to write our main function that actually, tells our server to start up and to use this handler function. So first we're going to tell it to http.handlefunc. So this is our way of telling it. We first give it a pattern. So this is the path. The next video, the aside video, covers sort of web requests and what paths are and how they're used in requests. So if you're not familiar with the path, finish this video, then go over and check that one out, and then you might want to come back and see this. But the way this works is you first tell it a path that you want it to use. So this would be like the end of a website. So for example, if I go to abc.com/dog/cat, the /dog/cat is the path part. The second part here is the function that we want to be used whenever that path is matched. With the built-in serve, it's called a serve muck. So with the built-in router essentially that decides where to send the requests, slash will get mapped to pretty much anything. So we're going to pass in this handler function, and it's saying that no matter what path they give us, it's going to send them to this handler function. So that's that function we wrote right up here. These two have to be the same. So next we're going to start up our server. So that's what this listen and serve is. So when you call it, the first argument is the address. I'm going to put :3000. So this stands for localhost 3000. The localhost is implied. You could write something like this, but you don't need to write the localhost part. It is implied. The port is the second part. It's the : and 3000. So normally web requests are on port 80 for unencrypted traffic, and I forget the port for encrypted traffic, but there's another port for HTTPS. And what we're doing is we're doing it on 3000 so that on our local machine we'll have to actually type in the port when we visit our page in the browser. But when we go to deploy later, we'll fix that stuff up so that it's not something that the end users ever have to do. And the last part is the handler. This would be like a handler function or a router or something like that we want to use. We're going to use nil for now. So what we're saying with nil is that we want to use the built-in serve mucks that comes with the HTTP package. And that's what this first line is using as well. When you call http.handlefunc, it uses the built-in serve mucks. Similarly, this right here, if you pass a nil, we'll use the same one. So this second line starts up the server, and this first line says that we want to use this handler function for all our requests. So now we are going to, well, first I just want to show you that we do have some changes here. You can see the get status. So we're going to go run main.go. And it looks like our server's running. If you want to verify for sure, you can go build. And then, we have this built version that we can run. So it's running. To stop it, it's Control-C. Even if you're on a Mac, it's Control-C to do that. So that's, a lot of things will be Command instead of Control on a Mac, but this one is one that's still Control. So we have this running. I'm going to go to our browser, localhost 3000. And you can see that we have this website showing up. Let me zoom in a little bit, but we've got this H1 tag. It's a little bit easier if you view the page source. You can see that we've got an H1 tag, and it has the welcome to my awesome site, and then it closes the tag. So it's everything that we wrote here is being returned to the web request. All right. So the other thing that I didn't really mention was that whenever you're Go building, by default, I believe it just uses the directory you're in. If you put a period at least to build everything, it uses the directory you're in to name the file that it's creating, the executable. There are ways to change that, but for now I'm just going to sort of let that be because it's the easiest thing to do. Now that we have our code working, we're going to go ahead and commit our changes. This is again one of those things that, like, if you're not following along the Git workflow, that's fine, but I just want to show you how this might work. So if I type git status, you can see that I've got these two files. I don't ever want this, this built executable to be committed right now. So the first thing I'm going to do is I'm going to .gitignore. So inside of here, I'm going to add this don't include our binary. So now we need to actually put the line that tells it to ignore it. So we put this lenslock.com file there, and you can see that this file is not there anymore, but we do have the gitignore and the main.go changes. So first thing we'll want to do is add the gitignore. So that's added here. You can see that we've added it. So I'm going to commit it and add a message, and I'm breaking this into two commit messages because realistically these two changes aren't that linked. I'd rather do the gitignore update as one commit and the main.go change as another commit. So I'm going to say, all right, git commit -m, added our binary to the git ignore file. All right, so then we're going to add the rest of the files, which is just main.go, and we're going to commit it. And we're going to say created our first web server. Put a little exclamation mark there. All right, so we've got our status here. So now we could check out master, and then you could, so the master doesn't have the git ignore update. That's why you're seeing this file here. So I'm just going to remove it for now, but I'm going to merge in 2.1, a basic web application. So since I've merged that in, it pulls all the changes that I had and it merges them in here and pushes them into master. So I'm doing this because my master branch is where I'm sort of keeping all my code. I broke into this other branch to do it, but now I knew I was ready to sort of push it into master, so I'm merging it. This is also something where you see people do pull requests instead of a merge like this. And a pull request eventually concludes in a merge, but it's one of those things where you're proposing the changes and letting people see them before they actually, merge it all in. But since it's just me, I'm just going to merge it in. So I've got the git status, I go git log, I can see all these commits. So we created our first web server. The one before that was we added our binary to the git ignore file, created a readme, and we created the git ignore. So those are all those. And then I can also, so I can git push origin master. So I'm pushing my master branch to origin. And now if I go here, I can go to GitLab and I can check it out. And you can see that we've got 4 commits, and you can even see, all the changes that we just did. So that's the basic idea with the git stuff. It's it's pretty neat and nice way to keep track of all your source code changes, and you can roll back commits, things like that, if you need to down the road. But realistically, it's something that you don't need to get too worried about until you're doing a lot more web development, and especially if you're working with other people. It's really nice to keep files synced, keep them somewhere else on the web in case your computer crashes, or to keep them synced between computers. But where it really shines is when you have multiple developers working together. All right, that's it. The next 2 videos, well, the next video that's not an aside video, we will go ahead and cover the code in this program in more detail in this main.go. But the aside video that we also have, it sort of goes over what a web app or what a web request is, and all the different parts of it to try to explain it so that you understand it a little bit better. If you don't really understand this response writer and the request, or like what is involved with a web request, I suggest watching that video because it'll really help you understand what these 2 pieces are composed of.